Okay, so starting a new topic today on sequences. First of all, we're going to have a look at doing this, recognising how things go up in patterns. You've probably done this before in primary school, so it might be a bit of a recap for a few of you. So have a look at this one here, this sequence here. What happens with this sequence? What happens? What pattern is there? You might see it goes from 14 up to 20, up to 26, up to 32. Okay, a lot of you have probably already realised that it goes up by 6 each time. So the rule is adding 6 each time. Okay, so that is the rule of this sequence. So if you're asked a question like, what is the rule of this sequence? What is the term-to-term rule? Term-to-term, each part of a sequence is called a term. Then the rule is plus 6. Okay, easy as that. Not always the case that it's going to be adding each time. Okay, you might have multiplying, you might have subtracting, you might have dividing. There might be completely different rules altogether. Okay, so when you're adding or subtracting each time, those are called either linear sequences or arithmetic sequences. I'm just going to call them linear for now because they go in a line. Line R. Linear means going in a line. Okay. This one, 84, 80, 76, 72. This time we're going down, aren't we? Okay. Are we going down by dividing? Are we going down by subtracting? We're going down by subtracting. What are we subtracting each time? We're going down by 4. So we're taking away 4 each time. Okay. Right, this one. 3, 6, 12, 24, 48. This goes up by 3, but this goes up by 6 this time, so it's not going to be an adding rule, okay? You might notice that it actually doubles each time. So we don't say rule doubles. We actually put this in proper mathematical terms, okay? We'd say times by 2, okay? That type of sequence where you're multiplying or dividing is called a geometric sequence, okay? I'm not too concerned about these names right now, but they will become more important when you get later on in your secondary school years, okay? Vast majority of the time you'll be focusing on linear ones, but these do come up. A surprising amount, actually, okay? Right, now over to you. So let's see if you can recognise the rules for each of these questions. Pause the video now, get a notebook out or your own book. Have a go at these questions, then I'm going to go through the answers. Okay, pause now. Right, let's go through some answers. So, we're just trying to find the rules for each of these. It just says what is the rule. 88, 91, 94, 97. Goes up by 3 each time. We're adding 3 each time. Easy as that. Now, important that you put the plus there, because if you just put 3, that just means 3. The rule is 3. That means each number is 3. Okay, if you put the rule as 3, that means it goes 3, 3, 3, 3, 3, 3, 3, and so on. That doesn't make sense. Okay, you've got to be plus 3 each time. Okay, what's the rule this time? 7, 5, 3, 1. It's going down, taking away 2 each time. This one, you're not adding each time, you can see, because it goes up really, really quick. You're adding 1, add 2, add 4, and so on. Okay, so the rule is you're multiplying. What you're multiplying by 2 each time, because you're doubling each time. It's not always times by 2. Sometimes it's times 3, times 4, times 5, etc., etc., etc. Okay. This one, we're starting on a negative. Ooh. How far are we going? If you think of a number line, how far down are you going? You're going down by 5. Are you going down by 5 again? Yeah. Going down by 5 again? Yeah. So you're taking away 5 each time. Don't get confused and put plus 5 each time, because even though it looks like they're getting bigger, remember, negatives, you're going down on the number line. So when you're going down, you are taking away. Okay? Right, this one. Those are decimal points, just in case you were wondering. If you didn't think that they were decimal points, pause the video now, have a go at that again. But I'm going to go through the answers now. Okay? So this goes up by 1.5 this time, goes up by 1.5 again, goes up by 1.5 again. You can have decimals as part of your rule, okay? This goes up by 1.5 each time, okay? This one, negatives again. What's happening though? Minus 20, minus 10, minus 5, minus 2.5. That's weird, isn't it? What's happening? It's gone down, it's gone up by 10, then up by 5, then up by 2.5. So it's not going to be an adding sequence, it's not going to be a taking away sequence, because what you're going up by changes each time. Is it going to be a times? Is it going to be a divide? Okay. Well, if it's times, that means it'll get more negative if you times it each time. If you divide it, it'll get less negative. How do we get from minus 20 down to minus 10? We actually half it. Do we half it from here? Yeah. Do we half it from here? Yeah. So the rule here is dividing by 2. Well done if you got that one. That one's quite a difficult one. Okay. Right. Next thing that we need to think of when we are talking about sequences is we need to talk about filling in the blanks. These are very common questions. Okay. Now we know how to find out what the rule is, we can find out what these blanks are. Some of you have already seen that if you carry on this rule, you're adding 5 each time, adding 5, adding 5. Well, we're just going to add 5 again, aren't we? What's 27 add 5? 32. What's 32 add 5? 37. Okay? This one, a little bit more complicated because we can't see exactly what we're going up by each time from the first set of rules. Okay? Even though the first set of rules doesn't give us a clue, we can use other parts of it in order to find it. What does it go up by with these ones? It goes up by 3, goes up by 3. Okay, so this one's going to go up by 3 as well. And working backwards, we could either work backwards from this one or work forwards from this one. If it goes up by 3 each time this way, it'll go down by 3 if we're working backwards. If it goes down by 3, that's going to be, whoops, might be useful if I actually can write 53. There we go. Right, this one, what's the rule? 64 to 32. Huh? To 16. Does that make sense? Yeah, of course it makes sense. You're halving each time. Okay, so if we're halving each time, that's going to be 4, because it's half of 8, and half of that will be 2. Okay. Now, this one, this catches a lot of people out, because we can't see directly how we get from here to here to here, because we don't have any information in the middle, and we don't have any information here to work that out as well. But we do know that every other number, these go up, every other number goes up by 8, doesn't it? So 8 to 16 goes up by 8. This goes up by 8 as well. We want to find something that's exactly halfway between 8 and 16. So what's halfway of going up by 8? Halfway of going up by 8 is going up by 4, isn't it? So if we go up by 4, that'll be 12. And the pattern continues. If we go up by 4 again, that's going to be 20. Up by 4, up by 4, up by 4, up by 4. Well done. That works. Okay, over to you again. Have a go at these questions in your notebook on a bit of paper. Up to you what you want to do. Okay, pause the video now. And by the way, that's a decimal point there, just to make it clear. That's a decimal point there. And that's a decimal point there. Okay, no other decimal points. Pause the video now, then I'm going to go through the answers. Right, let's go through the answers. Let's have a look, see what these go up by each time. Okay, that goes up by 4, that goes up by 4. So this is going to go up by 4, and this is going to go up by 4 as well. Nice and easy. We're going up by 4 each time. You don't need to write that as part of your answer. I'm just doing that there, just as a bit of a reminder. What's happening here? Okay, goes up by 5, goes up by 10. Oh, so we're not adding each time. Okay, what are we doing? Oh, we're doubling each time. So times them by 2 each time. So times that by 2, times 40 by 2, we're going to get 80. Double 80, we're going to get 160. Okay, oops, that's rubbed off. A little bit more complicated again. 0.5, 1, 1.5, 2. What's the pattern? You're adding, you're actually adding 0.5 each time. So if you add 0.5, you've got 2.5 there. Add 0.5, you get 3. Apologies if you can hear the construction site again. They are very irritating. Okay, what's happening with this one? Well, we can use this bit of information here in order to see what happens. How do we get from 15 up to 19? Well, we add 4. Okay, working backwards, if we're working forwards this way and it goes up by 4, it's going to go down by 4 going in the opposite direction. If we go down by 4, we're going to get 11. Does that work? Up by 4? Yes. Up by 4? Yes. up by 4, and then up by 4 again, we're going to get 23. Okay? Ooh, difficult one again. Okay? We need to see what's happening here. 18, 9, 4.5. You're not taking away the same amount each time, are you? So what's happening? In fact, it's halving. Okay? So it's dividing by 2 each time. So what's 72 divided by 2? It's 36. Okay? Half it, that works. Half it, yes, that works. Half it, brilliant. Okay? And then similar to what we had in this question at the bottom here, what's happening here? What can we do to see? To get from 6 to 16, it goes up by 10. Oops, goes up by 10. And that goes up by 10. So if we want to go halfway, well, what's half of 10? We're going to go up by 5, aren't we? Up by 5 is 11. Up by 5, 16, that works. Up by 5 is 21. Up by 5 is 26. Okay, that's a very quick introduction to some sequences. There are other sequences that may happen as well. Okay, this is just a bit of an extension. If you were still a little bit struggling with the previous work, shut off the video now and then move on to the next lessons. But if you want a bit of an extension and you've got a bit of time left, we could have a look at these. There are other types of sequences. The main one is called the Fibonacci sequence. Okay, that's how you spell it. I think it's an Italian name. Not entirely sure, but that might be Latin. And that is when you add the previous 2 terms. So Fibonacci style sequences, the classic Fibonacci sequence is this: 1, 1, 2, because 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, 3 add 5 is 8, 5 add 8 is 13, 8 add 13 is 21, and so on. Okay, this is a sequence that comes up a surprising amount in nature. Okay, and sometimes you might be asked to find terms in a Fibonacci style sequence. So you might be asked if you've got something like, let's start with 5, 7. How is it going to carry on? So 5 add 7 is 12, 7 add 12 is 19, 12 add 19 is 31, and so on. Okay, that's another type of sequence that potentially could come up as well. Okay, thank you very much.